Alright, so this is something that comes up a heap, and it comes up in exam questions from this moment on, because it's a great way to link calculus to the real world, and it's something you need to be very, very good at. If you do physics, it's a bit of a leg up, but it's not by any means a necessary requirement, but it does make it a little bit easier. And that is kinematics and calculus. Okay, so what we're doing is we're linking our mathematical understanding of rates of change and how things change over time with motion. So kinematics is all about motion. Rates, as we've expressed before, what is a rate, Maddie? How something changes over time. So what do we call a change in distance over a change in time? We have a special name for it. The distance I travel in a certain period of time. Speed. What do we call a change in speed over a change in time? Distance. Very, very good. In the past, you've got average rates of change, your average speed, or your average acceleration over a period of time. What calculus allows us to do is determine the instantaneous rate of change. Cool? So in the past, the way we've calculated speed is, well, we're at point A at 0 seconds, we're at point B at 5 seconds. The difference in the distance divided by 5 seconds is our speed. Whereas now, as long as we've got a function, we can calculate speed and velocity. So first of all, what are our units for position? What's a common unit for position or distance? Meters. What else? Centimeters, kilometers, etc., etc. You don't have to find anything other than that. Be aware you will be asked to go between those. So I might change the order of these. Centimeters, meters, kilometers. So if I'm going from centimeters to meters, I have to divide by 100. If I'm going from kilometers to meters to kilometers, I have to divide by, and vice versa. If I'm coming back, I have to times 1,000 and times 100. How many millimeters are in a centimeter? 10. Be aware of that. It doesn't come up often, but be aware. You will be expected to do those conversions on your own. Cool? Often represented, most commonly represented as xt and ht. Xt being usually when we're talking about a horizontal distance. What do you think ht is talking about? What's the distance that we would use h to signify? Height. So if we're dealing with height or position, every now and then it's represented as dt, but not very often. And sometimes as st, but again, less often. It's pretty crook to make it st. Why would we expect it to be st? Speed, but, yep. Okay. Speed's often, so just be aware, but st can be used to represent distance if we're talking about an old physics textbook. That's how they like to do it in the past. So, what about our speed or velocity? What are the units that we often come across for speed or velocity? What do you reckon, Zoe? Yep, so they're the ways we represent it, but what are the units we might use? So what are some units we might see? Meters per second, our most common, and the next one?
Meters per second squared.
That's one in front. Kilometers per hour. Cool. You won't be required to convert as much between those. I hope not. The only thing you need to know about, I guess, that conversion is how many seconds are in an hour. 3,600. People are probably thinking, how did Maddie do that? She learned it. If you don't learn it, what should you do?
It's right there.
What's between a second and an hour? What's a unit of time between a second and an hour? Yep, so I put minutes in the middle. How many seconds are in how many seconds are in a minute? How many minutes are in an hour? So if I times 60 by 60, what do I get? Cool, so do it that way if you're not sure. If you're going back the other way, it's divided. That won't come up much, but it's if you forget and it comes up in an exam, there's a way you can figure it out. And this is where the calculus comes in. We can find velocity by deriving our position function. So if I have a position function, I can find my velocity by deriving it. So if I want to know the maximum height, what do I need to do? The maximum height of an object, if I've been given a function. Same as any other maximum, I derive it, then what do I do? Let it equal 0. Why do I want to derive it and let it equal 0? What am I looking for if I've got a height and I'm throwing an object up? I'm looking for the stationary point. I want to see when the object is at rest. Sweet. Represented as VT or ST, we're happy with that. The last one, thankfully there's only one way we talk about this term, and it's acceleration. The units for acceleration, Xavier.
Meters a second.
And the units tell us a bit about this. Because what's our unit for length? What's this one? Meters per second. So we're saying change in that divided by change in time. Second, what about this one? We're deriving this one, so we're doing that one derived with time again. We find the velocity by deriving the, find the acceleration by deriving the velocity, and it is almost always represented as AT by itself. Yes?
Why do we use ST? Really confusing. S is displacement.
Yes, we don't often. More often than not, VT is how, and if I was you, I'd try and use VT as much, but I'm just warning you, and S can be used in both of these. Why? Because we're sick and we like to see kids suffer. No, I've got no idea why they do that. Cool? There are key terms, and you must write these key terms down because these come up all the time. I think they're the main two. We'll start with those two. We'll get further if we need. What does initially mean? Start. What? 0. It means that time equals 0. Clear? So if you see initially the positions here, initially means time equals 0. At rest, what does that mean? Speed equals 0, so Vt equals 0. Please do not confuse those. Happens very frequently. Sweet. Exercise, the same page we were on, but it's question 13 now, so I think it was, I forget it. It's chapter 10 review. Chapter 10 review, question 13. So this is a kinematics question. We're doing more practice of maths. Let's go.